Okay, this video will be going over Extrema on an interval homework. Okay, for number 1, we're going to look for our absolute extrema and local extrema. So for the first part, talking about an absolute max, looks like you're going to have an absolute max here at 2. So at x equals 2. And possibly over here at x equals 11. And then we'll have an absolute min. Looks like that's going to occur over here maybe at 1/2. We'll call that x equals 1/2. And also at, looks like a 7. And then we'll have our relative max. Looks like we're going to run out of room here. Our relative max looks like it's going to happen. It can't happen at an endpoint, so it looks like it's going to happen there at 2, x equals 2. And a relative min looks like that's going to happen there at 7. Okay, so number 2, same thing. We're going to look at our absolute max. Absolute max looks like it's going to occur for here at 2. And then we're going to have, doesn't look like we're going to have an absolute minimum because these endpoints don't stop. So there's not a closed endpoint like there was in number 1. But we can have our relatives. So relative max looks like it's going to be at 2 as well. And then a relative min looks like maybe at right here is where it turned down, so maybe at x equals -1. Right, number 3. This one, notice our endpoints, they're not closed and they're going both directions, so you're not going to have an absolute. So you can still have relative though. Relative max value looks like it's going to occur at -2. And then a relative min value looks like it's going to happen at +2. And the same thing over here. Now this one, it looks like it is stopping. There's no arrows there, so we can go ahead and talk about absolute max for this. And it looks like the absolute max is going to happen at 7. And we can have an absolute. On this one, I don't think we will have an absolute min from the way this graph is drawn. So let's talk about a relative max. Looks like a relative max we can do at x equals 7. And over here at x equals 10. And a relative min, that's going to happen at x equals 9. All right, moving on. Determine the critical numbers for each function below. So for this one, here, our critical numbers. A critical number is where your function's derivative equals 0, or, and this is something I forgot the other day in class, I didn't list it, f prime of x is undefined. So that's going to add a few more things to our answer in number 1. So what we have to do is find f prime. So that's going to be right here, remember the derivative of natural log. You drop that natural log. You take this as the denominator, and then take the derivative to find the numerator. So we need to set this equal to 0. So what you're going to do is set the numerator equal to 0 to get one of the points. So there's one of the critical numbers, and then set the bottom equal to 0. And that was the part that I forgot, where the critical point is undefined can also be it. So x squared equals 4. When you take the square root, don't forget plus or minus. And so your critical numbers, your CNs here, it's going to be 0 and plus or minus 2. There's your critical numbers. And now for our next part, we're going to look at the same thing. We need our f prime. So remember, this is the same thing as all raised to the 1/2 power. So the derivative is going to be 1/2 times x squared minus 9 to the negative 1/2 times the derivative of the inside. So fixing this and setting it equal to 0, those 2's are going to cancel, and so I'm going to have x over x squared minus 9 to the 1/2. And so now we need to go through and find our zeros. So we're going to have x equals 0. And then we need to set x squared minus 9. And we can do all to the 1/2 if you want to. Set that equal to 0. We would square both sides, so that gives me x squared minus 9 is 0. And then x squared equals 9. And then x is plus or minus 3. So our critical numbers for this one, it's going to be 0 and then plus or minus 3. And so now moving on to number 7, your critical numbers for it. Going through, you should have a critical number, and of course it's not telling you this, but notice you've got here at 0, you've got a horizontal tangent line. So that means right there, f prime of x is 0. And so right here, you've got a vertical. Right here, you've got a vertical tangency. So that tells you that f prime at 2 is undefined. And the same thing right here, f prime is undefined right there. So your critical numbers are going to be 0. You've got one at 2, and then one at 6. There's your critical numbers. All right, so for our next one, number 8, finding the critical numbers there. At first, people try to start factoring with this, but again, your very first step is going to be to find your derivative first. So again, we go through and find y prime. So y prime equals 6x squared plus x minus 20. And then you can, 2x, sorry. And then it looks like you can take out instead of y prime, let's go ahead and set it equal to 0. And we can divide out a 2 out of everything. So we have 3x squared plus x minus 10. And then we can factor this. We'll factor into 3x and x. And it looks like we're going to need a -5 and a +2. And then set everything equal to 0. Your critical numbers are going to be 5/3 and x equals -2. All right, and for number 9, you're going to have the product rule. So we've got s prime at t. You're going to have the first times the derivative of the second. So we're going to have 1/3 times 2t minus 5 raised to the -2/3 times 2. That times 2 is from the derivative of the inside, so that's first derivative of the second, plus second, which is the cube root of 2t minus 5 times derivative of the first, which is 2 times t. All right, so we've got a mess here. So s prime at t is going to be equal to, let's clean this up a bit. You've got, looks like, let's draw a fraction, and 2 times t squared is going to be on top, and it looks like 3 times 2t minus 5 to the +2/3 because I've moved it to the bottom. And then that's going to be plus 2 times t times the cube root of 2t minus 5. All right, and so we need to solve for t. So let's see, I'm going to set this equal to 0. And we have all this stuff. And then I think I'm going to subtract over, because there's really no x squared or anything, and that's when we need our factoring. So let's subtract over, just for grins, this portion here. So that's going to give me -2t times the cube root, or instead of writing cube root, let's write it to the 1/3, because I think it'll make this next step make a little bit more sense. So we're going to have 2 times t minus 5 to the 1/3. And then that's going to be equal to 2t squared over 3 times t minus 2t minus 5 to the 2/3. Okay, now if we take this portion and multiply it up here, then I have like basis, and if I add my exponents, then I have -2t times a whole 2t minus 5 equals 2t squared over 3. And again, that becomes a whole because you're going to add 2/3 plus 1/3, and that's going to give you 1. So that makes things a little easier there. Now I'm going to pull this out and come up over here. So now we're going to distribute, and we're going to get -4t squared plus 10t equals, and I'm out of room over here, 2t squared over 3. 2t squared over 3. Squeeze that in. Multiply the 3 over, so we have -12t squared plus 10t equals 2t squared. Subtract the 2 over, so we have negative 14t squared plus 10t equals 0. And so we can factor here. It looks like we can take out at least a 2 and a t. So that's going to leave me with negative 7t plus 5 equals 0. So it looks like we're going to get here a t equals 0 and t equals 5/7. And then we need to see where we're going to get an undefined at. And notice that we got this in the denominator, so we also need to throw out t being 5/2. Because that 5/2, if you set 2t minus 5 equal to 0, then that's going to cause a 0 in the denominator. So there's your critical numbers for that one. That one was a mess of a problem. All right, so number 10, same thing. You're going to go through and do your quotient rule this time. So g prime at x, you're going to have the bottom times the derivative of the top minus the top times derivative of the bottom all over the bottom squared. All right, so now multiplying all of this out, you have g prime at x equals 2x squared minus 18. And I'm going to multiply through with a negative and a 2x. So that's going to be minus 4x squared. And then that's going to be minus, so positive 6x. That's all over x squared minus 9 all squared. Okay, so now let's look and see. We can collect your like terms and set the top equal to 0 and then set the bottom equal to 0. So putting together the top and seeing, it looks like we've got negative 2x squared plus 6x minus 18. And we can factor out at least a negative 2. So it leaves us with x squared minus 3x plus 9. And that's not going to factor anymore. So then if we set the bottom equal to 0, we're going to get x to be plus or minus 3. And so there's our critical numbers. All right, so for our next problem, we've got our product rule again. So h prime at x equals, you've got the first times the derivative of the second plus the second times derivative of the first. So setting this equal to 0, it looks like you've got 1 plus natural log of x. And so we're going to subtract that 1 over, so negative 1 equals natural log of x. And a little bit of a reminder here that natural log, that means you've got a base e. So x is going to be equal to e to the negative 1. And so that's 1 over e equals x. Now the rest of the problems, I think, let's see. Nope, we've got these two problems we can do, but the rest of them is a calculator problem. And so see if you can do those with the calculators from my classroom if you still have them, or with Desmos. But here I don't have a way of showing you how to do it with the calculator. So if you want to stop at 13, you're welcome to do so. So looking at this, by hand, if you need to do absolute maximum, absolute minimum, which you possibly could, what you need to do is set up a chart. And in this chart, you always list your endpoints, so 1 and 6, and then you need to go find your critical numbers. So first thing is critical numbers. So we're going to find y prime and set it equal to 0. So I'm going to go ahead and just jump straight to it and say that's 3x squared minus 12x. And so we would go ahead and factor out a 3x, and that's going to leave us with x minus 4. And so that's going to give me a 0. That's going to give me 4. So there's all of my possibilities for an absolute maximum and an absolute minimum. So what we need to do now is go back and just evaluate these into the original function. So we need to find, well, what is y at 1? So y at 1 is going to be 1 minus 6, negative 5, plus 8 is going to be 3. Okay, and so now we need to find y at 6. So that's 6 cubed minus 6 times 6 squared plus 8. Now be smart about it. This is 6 cubed and so is that. So those are going to go to 0. So this is 8. Now we're going to do y at 0. So that's going to be 0 cubed minus 6 times 0 squared plus 8. Okay, so notice what that's going to be. That's going to end up being 8 as well. Now let's try 4, y at 4. So that's going to be 4 cubed minus 6 times 4 squared plus 8. So let's see what that is. You have 4 cubed minus 6 times 4 squared, and then plus 8. That's negative 24. Okay, so you have a couple of things here. Notice that you have an absolute max. That occurs at an absolute max value of 8 that occurs at x equals 6. And then you have an absolute 6, and it looks like it occurs again at 0. So 0 and 6, interesting. And an absolute min of negative 24. And that occurs at x equals 4. All right, so now we go through and do the same thing with 13. So again, set you up a chart. And you know negative 3 and 3, your endpoints. And then you've got to find your critical points. So go ahead and say 0 equals your derivative, 3x squared plus 2x minus 1. And then factor this. So you're going to have 3x and x. And you've got 1 and 1. Oops, I need to move that 1 back a little bit. So that's going to be a positive 1 and a negative 1 there. And so let's go through and finish this. So it looks like x is going to be 1/3 or x is going to be -1. So there's your two other candidates, 1/3 and -1. So we need to evaluate these. So y at -3, type that into your calculator and you should get -15. Then you evaluate y at 3. Again, you can type that in your calculator. And y at 3 gives you 33. I bet that's an absolute max. What do y'all think? Find y at 1/3. Y at 1/3 is going to give you -5/27. But that's min. And then we're going to find y at -1. Y at -1 is +1. So again, you can do all of those on your calculator, save you some time. And so 1/3 was -5/27, and -1 was 1. So you have an absolute max is 33, and that occurred at x equals 3. And you have an absolute min, and that one is -15, and it occurred at x equals -3. All right, so there you go. That's your absolute mins and maxes. You do set up a chart, include endpoints if it is absolute. Now, if it's relative, you don't. That's going to be a critical point. But absolute has to deal with your endpoints and your critical numbers. Now, the other ones on this is all graphing calculator, and there's no way for me to do a graphing calculator on it this way. If you have some issues with the graphs, please let me know, and I will try my best to talk you through it. All right, hope this helps.